Hi, Avi. I wanted to just get in respond to to this to this tactic that I was referring to. It's been bugging me and I think I've cracked it, and I just wanted your thoughts on it. So I had a chance to look at your AMAs. I think between the two, this one does not make sense for my tactic. This one does, and I'll just tell you why. So, I'll just click, if I click on it, this is what shows up. This is the fruit stand. I'm going to use this example itself to talk about this tactic that I've been talking about. And I'll tell you why am I discussing it in how it, in the Joanna problem. So just bear with me for a couple of minutes. So this was the one, 7 apples, 5 bananas, $63. And that's what I put in, 7 apples, 53, 5 bananas, $63. The total does not change. And I think your methodology was, just lay out the multiples of 7, go backwards, see how much you need to get to 63, and whatever that's needed. So 9 sevens are 63, so you don't need any more dollars to make up for that 63. So that's certainly, and 0 is a multiple of 5. So that's one value of 8 apples and bananas, 9 apples and 0 bananas. Now that does not count because you don't see a 9 in this example. The other only if you just keep working, testing values, testing if it's a multiple of 5, is this a multiple of 5, is this a multiple of 5, and you eventually get the 35. You get 4 apples and 7 bananas, and that happens to be the right answer. That's 11B. I wanted to take this one step further though, and I'll tell you why. I'll tell you how it leads to the Joanna much tougher problem. I wanted to understand the trend, and I noticed a trend. Whatever the value of x is, in any equation which is non-negative integers, you find any values of x and y or a and b, I noticed a very specific trend. The difference in the 9 and the next viable value of x, that difference happens to be the coefficient of 5, coefficient of the opposite value of b. And it just so happens that this difference, 0, is versus this value of 0 of bananas, if I'm just highlighting here, it just so happens that it's the coefficient of the value of x. Now, I don't think that is by accident. And by the way, I've tested this on other equations. I just threw out an equation randomly. 3x plus 5y, 31, x and y, no non-integers, positive integers only. And, I noticed that x and y can be 2 and 5. So 3 to the 6 plus 25, 31. And I noticed if I follow my trend, if I was to increase that 2 by y's coefficient 7, that becomes 7. And if I was to increase the value of y by x's coefficient, decrease it, because one has to increase and the other has to decrease, or vice versa, in order to keep that 31 stable, it's actually true that this is also a potential value of x and y. And I was amazed with this amazing trend I'm seeing, where I can actually, without doing any mental math, without doing any testing values, without doing any of this, if I know 9-0 works, I should also be able to tell that 4-7 works without any testing. If I can understand why that works, I don't even have to test for values, technically. And I'll tell you why that's so. In this case, I can test values, like a DS problem. I can test values, and I can get it right. But what I think it's really helpful is if it becomes much more difficult. Like, for example, and I think I know the reason why. Okay, I think I know the reason why this is working. The entire yesterday, I was trying to break my head, trying to understand it, because it just bothered me. I believe it has to do with the LCM. So going back to the apples and bananas question, I was trying to understand why is the difference between 4 and 9 5 and the difference between 7 and 0 7. So I think I've cracked it. It's because first and foremost the total does not change, 63. And the goal is to distribute that 63 between these two, um, I don't know what to call them, but these two different values. So, I cannot just distribute, you know, there's one way to distribute is put the 63 across the 7a and have 0. That's one way to distribute it. So that would mean apples is 9 apples and bananas are 0. But what if I try to distribute it? Let's say I try to distribute that 63, 10 plus 53. That won't work because I can't have 7 apples equals 10, because then I would have an integer, a non-integer. I would have decimal. And the same thing with b. I can't distribute 63 this way because it does not conform with my integer constraints, and neither also with my coefficient constraints. What if I try to distribute, let's say, I'm just throwing out 5 plus, what is it, 58 or something, 58, that adds up to 63. I can't do that because the 5 does not go into 7, the 5 does not go into 7a, the 58 does not go into 5b. What if I tried to distribute it 43 plus 10? So in this case, the 10 can go into 5b, giving me b equals 2, which is an integer, which is what I want. But I need to have, the 7a does not give me the 43. The only time that I can distribute 63 whereby 7a and 5b give me integers is actually based on the LCM on 30, which is 7 times 5. So 63 plus z, so this does not working, no, not working, not working. But let's see what happens if I distribute the LCM of 35, which happens to, I believe that's what's going on. That's the only way to explain it. The LCM of 35, if I was to distribute 63 over the LCM, so I would make this 63 minus 35 plus 0 plus 35. So if I don't know what 63 minus 35 is. 63 minus 35 is 28. So 28 plus 35. I can do that. And then this becomes 28 goes into 7a, a comes 4, and 35 goes into 5b, b becomes 7. What if I try to distribute 63 minus 35 plus 0 plus 35 plus 35? That does not work because then this becomes minus 7 plus 70. And given a and b have to be positive, that does not work. That's the reason why it's that spread of LCM that I'm having to spread that 63. That is why I'm getting these values as is, because I need to be, that's my analysis of what is going on as to why these x values, or a, in this case a and b, why are they following this coefficient? I'm not only looking for just testing values. I can certainly do that, but I'm trying to understand why, so as to internalize it. And I believe it has to do with the LCM of 35. And I've tried many equations, and I think it's coming to that. And I'll tell you why it's useful. I tried, so I'll tell you why it's useful. The Joanna problem. So S2 is obviously insufficient. S1, I obviously know peeking from into S2 that, X can be 10, the 15 cents can be 10, the 29 cents can be 10, that gives me 440. But if I was to take the L, can there be other values? I don't believe using the trend that I learned or I picked up from somebody else, I can actually check without doing any mental math, without doing any kind of analysis, the other ways it can only work is if 10 plus 29, because that's the 29 is the coefficient of the y value, which is 39, and y would have to drop by 10 minus 15 or minus 5, which is what I've written at the bottom here. And that's too large. If x is 39, 39 times 15 would be, it's too large. It's a little over 500. And in this case, y is negative anyway, so it doesn't work. What about if I was to say 10 plus or minus 29, which becomes minus 19, then this is negative. And y can be 10 plus 15 or 25. Too large. 25 as 25 times 29 is over 600, whereas I need something around 440-ish. I think knowing this, having this trend, understanding what values of x and y can work based on zero mental math can be used to solve a problem like this. That's why I'm trying to understand what's going on. Now, how would you have solved it? I will prefer making that into another video because this is getting too long. I just wanted your thoughts and how I've been using that, trying to get the LCM of the two coefficients as the way to distribute how to distribute that 63, and the only way to do it is through the LCM. I think that's my takeaway. And I'm telling you, I'm using that on takeaway for the Joanna problem. That's why I'm trying to internalize it. I just wanted your thoughts, your views. Thank you.